Good day everybody, and welcome to this series that I'll be doing on the imperial and the metric system. Today's lesson will be lesson number 2 concerning mass and weight. There will be 8 lessons to cover all the aspects of the imperial system and the metric system. If you have not seen lesson number 1 yet, I will tell you at the end of the video how to get there. The length and distance was lesson 1. Today's is mass and weight. And then there will be volume, temperature, pressure, flow, volumetric flow, and flow mass. And then currency I'm adding in. It's not really a metric system, but it has tendencies to look like a metric system. Alright, this is just a table showing a good comparison between the imperial and the metric system. Please have a good look at it. I won't go through it in detail, otherwise it'll take too long to do this video. Okay, this slide we see there's a 10 kilogram weight on Earth, Moon and in space. Newton values are shown for weight, where weight is in newtons, and it's equal to mass, which is the 10 kilograms times the gravity of wherever you are. Note that the mass is in kilograms, and it says basically how much matter an object has. That's what mass means. So this means how many atoms are in the mass. This cannot change. Even if you heat the mass, only the atoms may spread apart a bit more, and that will change the volume and the density, but mass stays the same everywhere, but weight changes with gravity. Just have a good look at the 10 kilogram weight in space. Because there is no gravity, there is no weight. No weight. There's mass, but there's no weight. Here we see the comparison of the Earth and Mars. The weight is 9.81 newtons on Earth, and it is 3.71 newtons on Mars. Now we see the weight on Earth, the Moon, and Mars and Jupiter. The Mars gravity is 3.71 meters per second squared. Jupiter's gravity 24.79 meters per squared, Moon's gravity 1.62 meters squared, and Earth's gravity 9.81 meters squared. There's some handy formulas for you to remember there. Weight is equal to mass times gravity. 1 kilogram force is equal to 2.2 pound. And the conversion from newtons to pound force is 1 newton is equal to 0.224809 pound. That's just a table showing the comparison of different places, which we just looked at now, with different gravities acting on the mass of 1 kilogram. Note also that 1 kilogram is equal to 1 liter of water, and then it shows the weights results in newtons. The units of mass, weight for metric is grams and kilogram, where the imperial is in ounces, pounds or stones. This shows us a good illustration showing that 1 liter of water is 1 kilogram, which is the same as 2.2 pound. Mass in the metric system, the base unit is grams, the larger unit is kilograms, and the largest unit would be tons. So if you see 1,000 grams is equal to 1 kilogram, and 1,000 kilograms is equal to 1 ton. Weight in metric is measured in newtons. In everyday life, we often use kilograms, but technically that is mass, not weight. Weight conversion in metric, weight newtons equals mass kilograms times 9.8 meters per second. That would be for Earth. On the imperial system, Mass in imperial, there is no single simple mass unit like the metric system. Imperial uses the slug. We will talk more about the slug later. Weight in imperial, pound force is the unit weight force. Weight equals mass times gravity. 32,2 pounds equals 1 slug times 32,2 foot per second, which equals 32,2 pounds divided by 2,2 kilograms times 9,81 meters per second squared, which will give us 143 newtons. So you might ask, where did the imperial ounce and pound and stone and the metric gram and kilogram originate from? And this is really from here where we are going to really see the difference between the two systems. In the imperial, the ounce comes from the Roman unit unca. If you can pronounce it uncia, maybe uncia sounds better. If you hear it sounds similar to the ounce, uncia. The uncia was 1/12 of the Roman pound, the libra. The pound, lb, is the units that we use, comes from the Roman libra. That's, you should notice there's a L and a B in libra. That is the unit of weight. This is why they've used the symbols lb. If it was from pound, we would have maybe called it PD or something like that. So that's why the lb, it comes from the libra. Today's pound is 16 ounces. The stone originated from literal stones used as weights. It varied widely until the medieval Britain wool trade fixed the stone at 14 pounds. A stone could be 8, 12, 14 or 16 pound depending on what was being sold. The wool stone, which is 14 pound, there was a glass stone, 5 pound, there was a beef stone, 8 pound, and there was a wax stone, 12 pound. Because the wool trade was the strongest trade at those days, the wool stone was the one that was chosen. So why did the stone still survive till today as a measurement? Basically, it's because of a strong cultural habit. It's a convenient size for body weight. People still today, especially in the UK, say, I weigh, for instance, 4 stone, 2 pound and 3 ounces, instead of saying I weigh 107 kilograms. It sounds better. And also the media and the health services continue to use the word stone. So that's why it's still around and surviving to this day. So what is a slug? A slug is the amount of mass that will accelerate at 1 foot per second squared when acted on by 1 pound force. 1 slug is equal to 32,174 pound mass lbm, because Earth's gravity is 32,174 feet per second. In metric, 1 slug is equal to 14.5939 kilograms. So, why does the slug exist? Basically, because the pound is used both as pound mass lbm and pound force lbf. LBM is how heavy something is, and LBF is the force gravity pulls with. Scientists created the slug so that mass and force could be separated, just like the metric system separates kilogram mass and Newton force. If you wanted to see what the uncia looked like, there's a picture of it. There's also a picture of the libra, the pound, and a picture of the wool stone, 14 pound, and a picture of the slug. Now, from here you will see how beautiful the metric system actually is. If you had to take a cube of 10 centimeter by 10 centimeter by 10 centimeter, That would give you 10 times 10 is 100 times another 10, which would give you 1,000. So 1,000 cubic meters. If you fill this cube, this 1,000 cubic centimeters with water, if you fill this with water, guess what? It will weigh 1 kilogram. And that 1 kilogram will be the same as 1 liter. It will be 1 liter of water that will fill this cube, and it will weigh 1 liter. This is such a trustworthy measurement for weight, using a 1,000 cubic centimeter size, and water, which is used everywhere in the world. Everybody knows what it is. So they've used nature to determine this. This makes length, weight, and volume trustworthy in one go. The one is complementing the other one. Therefore, 1 gram of water equals 1 cubic centimeter, which is 1 milliliter. Or 1 centimeter cubed is 1,000 cubic millimeters, which is 10 millimeters times 10 millimeters times 10 millimeters, which will give you 1,000 cubic millimeters. And if you had to change this cube into a meter length, then 1 cubic meter of water, guess what it will weigh? 1,000 kilograms. That will be 1,000 liters of water, which will be equal to 1 ton. So I think it says it all in one go, how fantastic the metric system complements itself. The metric, the gram, was defined by the French Academy of Sciences. 1 gram equals a mass of 1 cubic centimeter of pure water at its maximum density of 0,0353 ounce. The kilogram equals a mass of 1 liter of water, which is equal to 2,2046 pound. The ton, the metric ton, is 1,000 kilograms, which is equal to 2,204 pound. If you look at the imperial side, you will see how confusing this can get. 1 force pound is equal to 1/16th of a pound force. 1 ounce is 28,35 grams. 16 ounces is a pound. 14 pounds is a stone. The American ton is 2,000 pound, and the long British ton is 2,240 pound. None of these numbers are easy to remember. It's not like the metric system, which is 10 times 10 times 10. Yeah, you have figures like a 16th, 28, 16, 14, 2000. Very, very confusing. So the imperial system was a very, very confusing system, not easy to remember. Just looking at this demonstration, yeah, 1 gram is equal to 1,000 times, if you times 1,000 on a gram, will give you a kilogram. If you take 1 kilogram and you multiply that by 1,000, you will get 1 ton. And 1 kilogram times 907 will give you the US ton. That's the only difficult one of the metric system. The imperial values, 1 ounce is equal to 16 times 16 will give you 1 pound. 1 pound times 2,204 will give you 1 ton. And 1 pound times 2,000 will give you 1 US ton. Not easy numbers to remember on the imperial side. So why did the metric replace the imperial? Because the imperial was inconsistent. A pound could mean 12 ounces, 14 ounces, 16 ounces, or even 18 ounces, depending on the country. A foot varied from 10 inches to 12 inches in different regions. A gallon could be wine or ale, or it could have been corn, all different volumes. Metric is simple and decimal. The base is 10, easy for calculations. The units are defined by nature, not old traditions. It's better for science, better for international trade, and easier for education. Thank you for watching. Please like, subscribe, share, comment, and follow. And if you have not seen lesson 1 yet, please look for Imperial and the Metric System lesson 1, length, distance. Just type those things into your YouTube search and you should find the video. Be sure to check out the next video on Imperial System and the Metric System lesson 3. It's all about volume. Thank you.